Hi, this is Isaac from Geckology. Today I'll be doing a little bit of sharing concerning leopard gecko genetics. I hope you guys enjoy this video. Alright guys, so first things first. This is a normal leopard gecko, and a normal will be what leopard geckos look like in the wild type looking geckos, and they have no morphs. They're just a basic form. So this gecko here will be used extensively for me to show my examples. And here we have a very nice big male. This is a trampled albino, and this is the first albino to be discovered. There are 3 lines of albinos, but we'll touch on this first. The trampled albino is a simple recessive gene, and what this means is that when you pair a trampled albino to a normal, what you will have is a gecko. You will make babies that are normals that carry the gene for the male of the trampled albino. So all the babies produced are called what we call het. They will be het, 100% het for trampled albino. And what this means is that they will actually look like a normal type, but they will carry the gene of the trampled albino. And when you pair, let's assume now that we have 2 het trampers, and if you pair these 2 to each other, if you pair them back to each other, what you will make is 25% tramper, 50% het for tramper, and lastly 25% normal. So basically you will have a quarter chance to make back a trampled albino, and that will be easy. That is definitely easy to understand. But right now we have the rest, which is 50% het for albino, 50% het tramper, and this is the remaining, which is 25%, is normal. But looking at the geckos, looking at your babies, you will never know which exactly carries the het gene and which does not, which exactly carries the trampled albino gene and which does not, because hets are not exhibited visually unless there are certain markers which is not relevant here. They are not distinguishable from each other whether they are het or not, and so because of that, all babies are considered to be 66% possible het. And where did I get the 66%? Now 25 out of 75 here, which is 25 out of 50%, 25%, total is 75%, and 25 out of 75% would be 1/3, and 50 out of 75 would be 2/3, or 66%. So when you pair a het to a het, all non-visual offsprings are considered to be 66% possible het. And in the same way, if you pair, let's say this is a het and this is a non-het. When paired to each other, when paired to these two pairings will yield also a 50%, but 50% het and 50% normal, so half of each. But once again, because you do not know which exactly is the het and which exactly is the normal, so they will all be known as 50% possible het. And the only way to prove out these possible hets are by breeding them back to visual genes, or breeding back to het tramper animals, trampers to het or het trampers, and see if you actually manage to produce a visual looking trampled albino. If you manage to breed let's just say if you manage to breed a 66% possible het to a trampled albino and produce a trampled albino, then that animal that is 66% possible het becomes a definite 100% het, and therefore it proves out to be a het. But you can also go either way and not end up turning to be a het. So that's the basic understanding of simple recessive genes. And right now we'll go to another group. Now to my favorite pairing, snows. And what we have here in front of us now is 2 snows and a super snow. And this is a super snow, amazing looking animal, black and white contrast with full black eyes. And how do you exactly make a super snow? Now here, let me introduce what a snow is all about first. Essentially, the difference between a snow and a normal that I showed earlier is that a snow is born with black and white bands, whereas a normal is born with black and yellow bands. Well, this snow here might look a bit yellowish, but gradually max snows, when they grow up, the yellow will set in. But they are definitely snows if they are born with black and white bands. So anyway, a bit of genetics now. If you pair a snow to another snow, a snow to a snow, what you get essentially is 25% super snow, and 50% you get back snows, and lastly 25% normals. So you have a 1/4 chance of hitting a super snow from pairing a snow to a snow. And unlike the hets and possible hets of the simple recessives, everything here is visual. So you will know exactly what you produce after hatching your babies. So this is what the super snow complex is all about. And let us move on now then. Before I continue, a snow paired to a normal. Snow paired to a normal will give you 50%, 50%, with half of it being snows and half of it being normals. It's quite simple to understand. 50% possibilities for snow to normal pairing. And then now, let's switch it up a bit. Okay, now that we have discussed concerning super snows and trample albinos, let us bring in the combo. These are phantoms, or basically they are line-bred snow trampers. They differ according to their parentage, but as you can see, they have this very cool looking pinkish pastel contrast. So now, if you pair in the same way, just as a snow tramper to a snow tramper will give you the same odds of 25% super snow tramper, which is a very cool looking animal. Tramper albino version of a super snow. Super snow tramper albino. Then once again, half of it will be snow trampers, and the remainder will be 1/4 tramper albinos. Same one as the one earlier, same genetics, just a different example. So once again, in the same way, super snow, normal earlier, this will be a super snow tramper, tramper, and this is what it's all about. Now let us move on to Enigmas, yet another favorite morph of mine. Okay, now this is an Enigma, and as you can see, the Enigmas are born with a very nice intense looking colors, and with blotchings all over instead of the usual bands and jungle patterns. Enigmas have a very nice looking, they look awesome essentially, but they have a defect in the sense that they are affected in terms of they have this Enigma syndrome, where you have sometimes geckos with Enigmas tend to spin when they are stressed, or they tend to wobble, but they subject from one to another. Now an Enigma, when paired, Enigmas are dominant, which means that there's no super form of Enigmas. While a snow to a snow can make super snows, an Enigma can only make Enigmas. And the odds of pairing an Enigma to an Enigma is close to making, well, normally genetic calculators will give it a 75% to 100% chance of making Enigmas. And in my own experience, that tends to be true, as most of my Enigma to Enigma pairings yield a very high amount of Enigmas. But it's not a 100% sure bad thing. So anyway, Enigma to a normal works the same. Essentially, 50% each will produce half of each will produce a half of each. Just like a snow to a normal will produce half snows and half normals, an enigma to a normal pair will produce half enigmas and half normals. Now switch it up a little bit and let's bring in the enigma to a snow. And by pairing these two together, a snow to an enigma, what you will make is essentially this. When paired to each other, there will be 25% chance of an enigma, 25% chance snow, 25% chance normal, and the sweet spot, 25% chance of a snow enigma. And this here is one of my whole back snow enigmas with a wicked looking stripe. Snow enigma, definitely one of the most popular morphs in terms of simple combos. Snow enigmas, 25% chance of hitting them from pairing a snow to a max snow, snow to an enigma, sorry. Okay, now that we have done with this complex, let us now move on to one of the most popular morphs in Malaysia. Okay, now we have tangerines, and as you would know, this is a very familiar looking, ouch, this is a tangerine, this is a super hypo tangerine carrot tail, or in short we call them SHTCT, super hypo tangerine carrot tails. And these are bred from the first normals which had a little bit of tangerine influence were selectively bred to each other to arrive at such an outcome after years of breeding to each the best of the best looking orange ones to produce such a distinct looking morph. And this here is a sunglow. And what a sunglow is basically an albino. This is a tramper albino sunglow, which most sunglows around are basically tramper albino, of the tramper albino lines. So normally you will see that people omit the word tramper. Normally sunglows is anonymous to tramper albinos, but there are also different lines of sunglows such as bell sunglows and rainwater sunglows. But tramper sunglows are the most common ones, and unless noted, basically if you have a sunglow, it is highly likely it is a tramper albino sunglow. And basically what sunglow is it is an albino SHTCT. So this bred to a tramper albino earlier will make you this. Basically this and this will make you a sunglow. It's a combination of these two. When a sunglow bred to a SHTCT, just like how a tramper to a normal, you will make 100% SHTCTs that are het for tramper. Once again, just like a normal het for tramper, this is a SHTCT het for tramper. And if bred to each other, if assuming these two are het for trampers, when bred to each other, the same outcome will apply just like how we discussed earlier. 25% chance of a sunglow. And once again the 50%, 25%, 50% het, 25% SHTCT, SHTCT het for tramper. And like earlier, you will become 66% possible hets. And needless to say, the same rule applies when if you breed a het to a non-het, babies are all 50% possible hets. So these are what tangerines are all about. And the beauty of tangerine animals is that you can actually line breed them, which is by breeding the best looking tangerines to each other, you can actually make animals that even look better. Hold on, if I can give you an example. Now a good example of line bred tangerines will be one of these. This is one of my hot gecko line females. She will be a breeder in my facility. And basically what tangerines are all about is that you can breed them in such a way that babies will look will have much intense colors compared to the parents. So if breeding a tangerine to a tangerine, you can actually make even more intense looking tangerine animals. And so if you are, and therefore pricing is highly affected by the how they look. If you are deciding to buy an SHTCD or hot looking animal, you have to take note that there are many lines of tangerines available in the market. Like in Malaysia, we have the hot gecko line tangerines, we have what we call an extreme SHTCDs, and also we have tornadoes, tangerine tornadoes, and some other line, which are among the more common ones. And my advice to you, if you are deciding to buy a tangerine gecko, is that you should buy not according to its name, but according to the quality and intensity of the orange. That means basically is, the more orange it is, the higher you should fetch, or rather that's what you should look for when you are looking out for tangerine animals. Alright, now that we are done with tangerine animals, let us touch a little bit on the slightly complex double recessives and triple recessives. Okay, now a little bit more on the recessives, as I was mentioning earlier. Well, as you notice, this is a trample albino that I showed. Trample albino, and this here is an eclipse. And an eclipse essentially is a full, not exactly full, but eclipse are born with very nice looking, very cool looking stripes. And also they have either snake eyes or usually full black eyes, jet black eyes, which are not related to the super snow full black eyes. These are genetic black eyes. Whoa. And this guy is mad here. Okay, and when paired to a combination of these two genes, the tramper and the eclipse, is this. This is a raptor, and I'm sure many leopard gecko keepers would be familiar with this morph. This is an albino version of the eclipse. This is a raptor, and what it stands for is a red-eyed, ruby-eyed, albino, patternless, trample orange raptor. So anyway, it's a very cool looking animal, with either classic patternless or reverse, or nice reverse stripe. Okay, this is a very feisty one. Okay, now we have a raptor here, and this here now is a Murphy patternless, or also known as a leucistic, or patty for short. And you throw in the raptor earlier with the patty. A combination of these two will make you the amber. And what an amber is basically a raptor patty, patternless, Murphy patternless raptor, and it's a very cool looking animal. Basically, this is a triple recessive animal: eclipse, tramper, raptor, all in one. Okay, let us touch a little bit then on how do you make one on the odds. Before touching on the amber, let us just use a raptor as it is a very relevant example. Raptor, when paired to a normal, I'll just use a bigger version of a raptor. Just give me a minute. Alright, a normal paired with a raptor. Just like how when pairing a normal to a tramper, you will make 100% hets, and in this case it is 100% het raptor. And what is a raptor? Like I said earlier, it is a combination of the tramper and eclipse gene. So basically, instead of being het for only one, it is now het for two when it's a het raptor, double het as we call it. And breeding a double het to a double het is not the same as breeding a single het, which is just like, for example, when breeding a het, as you know earlier on, a het tramper to a het tramper breeding will give you 25% chance of a tramper, 50% chance of het trampers, and 25% chance normal. This is single het, single het. Now breeding a double het is totally different. And in this case, right here we have, let's assume that these two are het raptors, and we are going to pair them to each other and see what we can get. Well, you know that a het tramper to a het tramper gives you a 25% chance of producing a tramper albino. And from now on, to keep the discussion easier, we'll use fractions instead of decimal points. Like from earlier on, we have discussed concerning odds such as 50% and 25%, which is basically half, quarter, and actually if the more complex the calculations are, the lower they can actually go. So you have 1 over 8, 1 over 16, and so on. So the more genes in an animal, the higher the amount of fractions that we have to deal with, the smaller the chances of hitting them. So we will get back to that shortly, but let us go back to the het raptor to het raptor breeding. And as tramper to a het tramper gives 1 over 4 chance of hitting a tramper. A het raptor to a het raptor gives 1 over 4 for the tramper. So basically a het raptor would be a het tramper and het eclipse crossed with a het tramper to a het eclipse, which was the double het that I was explaining about. So now a double het works in such a way that instead of 1 quarter now, it will be a 1 quarter times 1 quarter, because you're trying to hit both the odds, combined possibilities. You learn that in basic maths if you are schooling, but I'm sure plenty of us will have forgotten that. Quarter to a quarter, which is 1 over 4 times 1 over 4, gives a 1 over 16 chance of hitting a raptor. And that is 6.25%, which is considerably low odds. So you have to be extremely lucky when pairing a het raptor, double het raptor to a double het raptor, or double het recessive, any double hets, any double het projects. The odds are definitely much lower compared to single hets. And right now, before going any more further, I'll just need to clarify this. A het, this would be a normal, that is het for raptor, hence a double het. Whereas you can also have animals that are single het, which is like, just give me a minute while I find an example. And this would be a tramper albino het for raptor. When we say het for raptor, we don't mean it as a double het. Basically, it would be, as it already has the tramper albino gene, it would be only het for eclipse. But the common way of putting it is het raptor, as you are trying to make raptors. The eclipse is the other half that is lacking, so hence the het. Het eclipse basically is also a het raptor, but this works as a single het because it is only het for 1, whereas the normal earlier is still a double. The normal earlier is basically still a het tramper, het eclipse, hence double het. And so if you are looking at the higher the combination, such as snow, and some people tend to ask me, what's the difference between a max snow tramper enigma het raptor and a max snow enigma het raptor? Well, essentially that is it. You're looking at one that has half the equation of the raptor already visual, so hence a single het and a double het. And that makes up a lot, especially when you are trying to breed for the best outcome, as the possibilities tend to get lower and lower the more genes you're playing with. So this is basically what double hets are all about. And without a doubt, if you're dealing with single hets, you're dealing with 1/4 odds to hit the target. In double hets, multiply the quarter by each to make 1 over 16 odds. And without a doubt, triple het breeding, crazy enough play with is 1/64 odds, which is like basically what this odds means is that the probability is that by right every four eggs you hatch, you produce one. And then double het, by every 16 eggs you hatch, every 16 babies there will be one, and every 64 babies there will be one. So basically, if you can hit a triple pairing, that's a jackpot for you. And we won't go too deep and touch on quads and so forth. And let us now mix and match a few select breedings to let you have an understanding of how exactly do you calculate breeding. I will not be touching on the different outcomes, as you can have genetic calculators to help you on that, but I'll teach you on how basically you can think of off the back of your head what is the possibility of hitting a certain animal that you're targeting. Alright, so into our last segment now. Okay, let's do a few practical examples on what you're trying to pair. Here is a raptor, and here we have one of my favorite babies that I hatched last year. This is a dreamsicle, or basically a snow raptor Enigma. And let's just say we want to pair them both to make a dreamsicle. A snow, as you know, paired to each other, the possibility of hitting a dreamsicle is such as this. A raptor to a raptor pairing is 1, or raptor to raptor is definitely a 100% thing. So 100% is, let's use the fraction of 1, full fraction. And now the snow is as 50%, so 1/2. And Enigma is also 50%, which is 1/2. So based on this pairing, the odds of producing a dreamsicle is 1/4, or 25%. Alright? Then let's just say if I want to pair, this is a normal het for raptor. Normal het for raptor to a dreamsicle. So a het raptor to a dream. Normal het raptor. So what we have here is a het raptor to a raptor pairing. I forgot to explain this to you, but a het raptor, as a het tramper paired to a het, you'll be 50% tramper and 50% het. Alright? And so a raptor, or double recessive to a het, double het, it will be a quarter, which is 25% raptor, 25% tramper, 25% Eclipse. Although there are some debates on that, we will not touch on the technical aspects of things. We'll just touch on the technical aspects of things, and 25% normal. And definitely all these non-raptors are het for the rest. So het raptor, het raptor, het raptor. So this is what it's all about. So I may have missed out on explaining that. And let's go back to the pairing now we have in mind. Normal het raptor to a dream. A het raptor to a raptor gives you a quarter odds, 1/4. Then combine with the snow earlier, 1/2, and the Enigma, 1/2. So if a het raptor paired to a dream, you will have 1/16 chance of producing a dreamsicle. Right? And just a few more before we wrap things up. This will be, hope you all understand how to look at genetics and calculate them. Alright, I'll just show this real quick. This is a Super Snow Bell Enigma, or what we call Bell Dalmatian. And let's just use him as a male now. And let's just say we'll be pairing it to snow. Alright, let's just assume that this is a super snow bell. This is a super snow bell enigma, and here we have now is a snow het bell, max snow het bell. So super snow bell enigma pairing between to a snow het bell. What are the chances of producing a super snow bell enigma? Okay, super snow paired to a snow, you will have just like super snow paired to a snow. First of all, gives you 50% chance of making a super snow and 50% chance making a snow. Right? So now we have the SSBE, the Bell Dalmatian, paired to a snow het bell. What you are trying to hit is a super snow bell enigma, and the odds are super snow to snow will give you a 50% chance of making, 1 over 2 chance of making a super snow. And then, whoops, it's getting horny now. Enigma to normal, which is another 50%. And now the bell to a het bell. As I showed earlier, a tremper to a het tremper gives a 50-50 outcome. In the same way, it is a 50% chance. And so you have now 1 over 8 or 12.5% chance of producing a super snow bell enigma. Alright, and one more example, and I hope you guys will understand what I'm trying to tell you now. Alright, now I'll use this will be a slightly complex pairing to discuss calculations. This here is a black hole or a max snow eclipse enigma, het for tramper or het raptor. So a black hole het raptor, and this here will be a tramper enigma, one of my tangerine tramper enigma, het for raptor as well. Alright, so what we have here genetically is snow, eclipse, enigma, het or tramper, paired to a tramper, enigma, het for eclipse or het raptor. Alright, so the odds now are, once again, snow 1 over 2, and for the sake of discussion, let's assume that the enigma to enigma pairing is 100%, so it's 1. And now an eclipse het tramper to a tramper het eclipse. This is a bit interesting now. An eclipse to a het eclipse will be 1 over 2, correct? A tramper to a het tramper, once again, will be another 1 over 2. So what you have now to make, in order to make a snow raptor enigma, or basically the dream seeker as I showed earlier, will be 1 over 2, 1 over 2, 1 over 2, 1 over 8. This will be the odds of producing the best outcome for this pairing. And I hope my simple video has been helpful, especially for those of you who are interested to venture into breeding genetics into morph animals. Well, apart from leopard geckos, most of the reptiles that I deal with genetics involve such calculations and understanding. And so whether you are a leopard gecko keeper or maybe even a snake keeper, I hope my video has been of assistance. And thank you for watching once again. For more information, you can check out my website www.geckology.net.